with 4.4 trig functions of any angle, we've kind of already talked somewhat about this to a certain extent, where we have points in other, because we've already done like the unit circle project and stuff like that, so we already have points in all four quadrants. So whenever we have the different points in different quadrants, basically all this says is that we can find any angle of any spot in our on our coordinate plane, because we can just make with whatever angle we're given. Remember, so like if you have like a terminal side, that's basically it leaves from the x-axis on the positive side, and then it just wraps around. The one thing that I would make sure that you pay attention to with any of these is to see which way the arrow is going. For the most part, everything here, the arrow is going to go in a positive direction. Okay, but just be aware to see like what that is, where it's basically almost completing the circle. That just tells you how the angle's going. Okay. Although we have the angle measurement, like if we go all the way through to quadrant 4, where we have the angle of our triangle here that's in yellow, the actual angle that we're dealing with from here to here is the green part. Does that make sense? Because of where this arrow is going. So because of how it's wrapped here, okay, in green, that's showing you kind of the direction that everything's traveling. That's not going in a negative direction, even though it's going to work out to be the same thing. Okay, or we can find that. We can kind of go from there. So whenever we do this, remember a few things that we've already talked about. Everything in quadrant 1 is positive. Everything in, and there's some of this in the notes, but we've already talked about it, so we'll just talk about it now. Remember that the point here, it's going to be negative x and a positive y if it's in quadrant 2. If it is in quadrant 3, then both x and y will end up being negative. Okay? They just give us, like, the point that they give us is just x and y, but like what I'm writing is basically just what you can remember. And then here your x will be positive, bless you, and then your y will be negative, okay, for anything that lies in quadrant 4. Okay, so whenever we have our trig functions, okay, because again it's a circle, we can always draw a right triangle, okay, no matter what. If you notice that your radius, like as your circle or r, it's always going to be the hypotenuse. So whatever your terminal side of your angle is always going to be your hypotenuse. That will never change. Okay, notice here, and then you just always use the x-axis as one of your sides, and then you just drop down a perpendicular line to make the third side of your triangle. Okay, so your terminal side of your angle will always be your hypotenuse. The x-axis, wherever it's at, either on the positive or the negative side, will always be one of your sides of your triangle. And then like your y side, or your second, usually your longer side is kind of how it works. Not necessarily always the case, but your kind of your open side is always going to be the other side of the triangle. So whenever we have any of this, so sine of theta, so it says let theta be any angle in standard position, let P be your point on the terminal side, so basically whatever your point is that you're given. If r is equal to the square root of x squared plus y squared is the distance, okay, it's just distance formula, from 0 to wherever your point is, x, y, as shown in like the figures that are above it. So whenever we do this, we always have sine of, remember, sine goes with y, Okay, cosine goes with x. Tangent goes with sine over cosine or y over x. So just like whenever we did with our hand, right? Okay, whenever we did the reference angles like the 30, 60, 90 with our hand, remember, my y value was always my sine, my x value was always my cosine value. So none of that's going to change here. Okay, none of that changes down here in this yellow box that we have. That sine still deals with y, cosine still deals with x, and we're just going to put it over our hypotenuse. And then remember, sine is tangent over, or excuse me, sine over cosine or y over x. Cosecant, it's just a reciprocal of sine. Secant is just a reciprocal of cosine, and cotangent is just the reciprocal of tangent. Okay, bless you. And then down here, kind of that little box that's in the gray where it says the ratios in the second column are just the reciprocals. We already know that. We've already talked about it. It hasn't changed since we started. The easiest way to think of it is R is your hypotenuse of your triangle. Okay. So then here it says let P, which is your point, be -3, -5, okay, on the terminal side of theta. Find each of the 6 trig functions of theta. So we have sine of theta, we have cosine of theta, we have tangent of theta, and then we'll have the other 3. Okay, we'll have cosecant, we'll have secant, and I'm way off. We'll have secant and then cotangent. So the easiest way that we can do this, or the way that I believe anyway, is if you need to draw your triangle. Where's negative? What is it? -3, -5. What quadrant is it going to be in? Or where's it going to be at? Third quadrant, right? So it's going to be bottom left. So if I have a point at -3, -5. So basically what I'm going to do is I'm going to go over to -3. I'm going to go down to -5. Okay. So that's -3. Here's -5. All I'm going to do is then create my triangle. Okay. It is going to, my angle is going to come all the way from here. So that means that theta's inside there. Okay. Theta will always be made up by the x-axis and wherever the origin is of my, wherever the origin is on my graph. So I need to know a couple things. Okay. I have 2 sides of my triangle. Which one am I missing? Am I missing the radius? Am I missing the, or excuse me, am I missing the hypotenuse or one of the 2 other sides? Aren't I missing the hypotenuse? Okay. So it's really, you solve it however you want. You know, it had r equal to the square root of x squared plus y squared. Okay. It's really up to you as far as what you do. That's just Pythagorean theorem, right? Okay. It's going to do the same thing. If you're looking for r, all right, r squared is just equal to x squared plus y squared. It's the same thing if we do the square root of -3 squared plus -5 squared. The thing about this is, for our radius, you should never end up with a negative value, because that squared is going to take care of everything that we have. So if I have the square root of 9 plus 25, so my r, or the side of my triangle, is just going to be the square root of 34. We either used distance formula, we used Pythagorean theorem, we used the new formula they gave us. It's all the same. Okay, that's the biggest thing that we can't get caught up in, that this is the same thing as Pythagorean theorem. This is the same thing as the distance formula, because if we leave from 0, all right, it works out to be the same thing, right? Distance formula, Pythagorean theorem, this formula, it's all the same. It's just the letters change. Okay, the variables change is the only thing that's different. So if we're going to set everything up, then all we have to do, okay, so I have the square root of 34. Sign goes with x or y. Goes with the y, right? So my y value is -5. So if you need to put down -3, -5, and you need to know what everything is, so I'm going to have -5 over the square root of 34. Now I can't leave it like this, so I'm going to rationalize everything, and I'm just going to have the square root of the square root of 34 over the square root of 34. So then -5 times the square root of 34 over 34. I'll do the same thing again with cosine, but now instead of it being a -5, it's going to be a -3. It's still going to be a 34 on the bottom side. I still need to rationalize it and have the square root of 34 and the square root of 34. It's still as easy as it was before, and have the negative square root of -3 times the square root of 34 over 34. Tangent's simple, because it's just y over sine over cosine, or y over x. So -5 over -3 is just going to give me 5 over 3. Now, hopefully, again, this is one of those things that you can make this a lot easier on yourself. Do we want to re-rationalize the reciprocal of -5 times the square root of 34 over 34? Do we want to flip it and then have to re-rationalize this thing again? No. Where's the easy place to look on both sine and cosine? Can we just flip this one and flip that one? Now, it's not always going to be the case, but for the most part, it's going to be the case. So the square root of 34 over 5, negative square root of 34 over 3, and then 3 over 5. It does the same thing, even if you have to think about it as, like, if we have theta, we have opposite, here's adjacent, here's my hypotenuse. Okay, sine is opposite over hypotenuse, right? Well, opposite over hypotenuse, which is down here, it's all doing the same thing. Okay? Whenever we create our triangle, okay, it's all the same stuff that we've done before. It's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. None of that's changed. Okay? It's still making a triangle, figuring out that you have all three sides of your triangle, and using the trig functions. So then again, what happens? So it says evaluate if possible the sine function and the tangent function of the following four quadrant angles. So basically if you land on the axis, again, this is all stuff that we've talked about before. Remember, sine is your y value, tangent is y over x. So as far as where you have everything, if you're at 0, what point on my graph am I? If I'm at 0, what's my actual coordinate? 1, 0. So as far as sine, do I have what's my y value? What's sine of theta? Which is 0, right? Okay, because it's my y value. Same way with tangent. What is sine over cosine, or what is 0 over 1? Still 0, right? What's going to happen if we have a 90-degree angle? What are my two values? Okay, what's my coordinate if it's at 90 degrees? 0, 1. So then sine of theta, again, is my y value. So it's 1. What's the problem with tangent, though? Can I do tangent? Can I do 1 over 0? Nope. So we just go no solution or undefined. You're really just looking at your main coordinate, okay? Because it's going to be the same thing regardless. I believe the last part where it's the sines of the, we've already talked about this kind of at length. Kind of the acronym here, we have A, we have all sines, sines positive, tangents positive, cosines positive. Okay, stuff we've talked about before already. It's actually on the back wall and it's on the front wall. So none of those as far as where it says positive and negative. That's all stuff we've seen and talked about before. What it just gives us is really, if tangent is negative, so it says when tangent is negative and cosine is positive. So where is tangent negative and cosine positive? Where's the only place? It's one of two places, right? Okay, the big thing is look to see where is everything positive. Okay, so it's either going to be into 1 or 4, but the problem is this one's negative, so it's going to be in quadrant 4. Now on 6, where it says tangent of theta is equal to negative 1/3, okay, so that means you have either cosine or sine has to be negative. Remember that tangent of theta is sine over cosine. This part here tells you that cosine is negative. So if I have a 1 and a negative 3, essentially, where is cosine negative and sine positive? Quadrant 2.